So today we'll first talk about the logic probe, and um, and then we'll get ready for our next lab. Okay. Now remember, you all bought a logic probe, which is a device we use to, which is the equipment we use to debug and troubleshoot the digital circuit. Okay. And by now you probably have realized that even if you build the circuit correctly, if you follow all the schematic procedures and everything, it's still possible that your circuit may not be working. So a lot of times it's actually hard to tell just by looking at the circuit whether why the circuit is not working. Okay. Now in those situations, uh, logic probe is actually your friend. And also remember, in this class the troubleshooting is also part of the lab. So starting from the next lab, which is lab 4, we will also let you troubleshoot your circuit if it is not working. Okay. Because after this lecture and after doing this the quiz that we have for the next lab, uh, we should be able to work with the logic probe, which is something extremely important and integral part of the digital circuit troubleshooting. Okay. Now let's first check what we have in a typical logic probe. I know that you have logic probes from different brands that look different. Sometimes they look different even in their shape, but they still have some of the things very common no matter what brand you have. Okay. So you will have a red light and a green light for sure, and a yellow light. Okay. So most of the time you probably will not need the yellow light. So the green and red are the ones which actually indicate the logic that we need. So the red light always will indicate the logic 1. Okay. The green light will always indicate the logic 0, and make sure you also have a couple of switches, so make sure you keep it in the normal mode, because this logic probe, the logic probe that you use, is also good for pulse circuit. We're not talking about the pulse circuit at this point. So make it normal, and also make sure it's also in the TTL mode, because most of the ICs that we use in the lab are actually belong to the TTL group of the family of the group of the ICs. Now, whenever, as I said, whenever you see the red light, it will actually give you a high pitched tone also, which indicates that that point, whatever you are touching using the probe, that point is high at this point, at this moment. Okay. Now using the green LED, if it is green, if you touch any of the point in at your circuit, any pin or any connections or any columns or any LED or any register, any end of the register, if it is green, that means that that point at that moment is 0. Okay. Because remember, in the digital circuit, all that matters to us is whether the point is 0 or 1. Okay. Now we always will use the normal setting, as I said, and make sure the TTL is also selected. Okay. Now logic probe is, as I said, is an equipment, so it also needs power supply. Okay. So with your logic probe, you will see there are 2 wires connected. One is black and one is red, and as you can guess that you have most of the time a 2-foot long set of power LEDs, which should be connected to voltage 5 and ground. So the black wire should be connected to the ground, the red wire should be connected to the VCC. Okay. So you can actually do this. You can connect the black one with the ground bus of your breadboard, whatever the ground bus you have, and you can at your breadboard. Okay. So you can take the power from the same source, but remember, the logic probe will not work unless you power it up, because it needs power supply. Okay. I also wrote it here just to make sure that the red LED goes to the voltage 5, and the red wire go to the voltage 5, and the black LED, the black lead, meaning the black wire, and goes to the ground. And both of these wires has alligator clip, so you can connect it very easily. Now, in digital electronics, there is, we actually, it doesn't matter that what is the voltage. As I said from the very beginning, that it doesn't actually matter to us what exactly is the voltage, okay, at this point, in some point. It's actually important that what logic we have, okay. So digital logic probe is used to detect the logic levels, right? So we just want to know what point is 0 and what point is 1 at this point. So usually this is what happens. You actually don't need to know this very detailed, but I just wanted to show you, just as a quick reminder. So if any point, if you have a voltage between 0 to zero point 0.8 volt, your logic probe will tell this is a logic 0, okay? Or if it is 2.2 or 2 point, if it is between 2.2 to 5 volt, it will identify that point as VCC, meaning as high, okay? And if it is in between, like 0.8 to 2.2, your logic probe will not be able to identify the logic, because it's hard to tell what the logic is, because this is something in between, which should not be the case in any of the digital circuit that we'll be building in the lab, okay? Because if something like this happens, that your voltage is between 8.8 to 2.2, that means your circuit is not working correctly, or something is seriously messed up, okay? Your IC might not be correct, or something else is performing wrong, so for sure. So most likely you will get like low or high most of the time in any of the point. Now let's see how we actually use the logic probe to check a circuit, so whether the circuit is working or not, okay? Now, to check a circuit, you definitely need the schematic of the circuit with all the pin numbers, okay? So for all the circuit that we build in the lab, we provide the schematic, right? So you have the schematic in your manual. You also have another copy of the schematic in POS under the lab section. So for every lab, you have a schematic. Remember, we need the schematic with all the pin numbers before we even try with the logic probe, okay? Now let's say this is our circuit, okay? This is our circuit which we are trying to build. This is the schematic with all the pin numbers. Do you see the pin numbers there for all the IC? Now, just by looking at this schematic, can anyone tell me that how many ICs I'm using here in this schematic? Just by looking at the schematic, can you tell? We actually are using 3 different IC, not 4, 3, because this 7404 belong to one single IC, right? Now all the 7400 belong to another IC, right? Because in one 7400 we actually have more than 3 NAND gates, so you can just use one IC. And the very rightmost one belong to another IC, which is 7410. So you actually have 3 different IC here, and you have the pin numbers for those ICs. And we also know that how we get the pin number, right? So even if you don't know the pin number, you can always find the pin number at the back of the manual, where you have those data sheets, right? You have data sheets for all the ICs that we use in the lab. So you can get the pin number from there, and you can write it down before you even start, just to make sure. Okay, now let's say you also know that all the truth table of all the gates, right? See, because you already have it, right? Remember, I already gave it to you. You already have it in the POS, that you have the logic meaning the truth table of all the gates, right? All the basic gates, and also the other gates that you know, okay? And you also should be you also should know what you should be expecting, because before you even make the circuit, you know exactly, let's say this is what you want, okay? Now for an example, at any point of time, you are starting from the beginning, okay, to check why your circuit is not working, okay? So let's say you follow through each iteration and see why the circuit is not working, okay? So use the logic probe to verify each point, like each node on the schematic. So let's say, how do you start? Let's say, for an example, my first row is not working. That means I was getting a 0 or something here, and I wanted to double check whether this is exactly what I should be getting, okay? How can I check it? So this is how I check it. You have completed all the quizzes. This is pretty similar to the quiz that you have completed for lab, from chapter 3. So what I do is, for A, B, and C, for the first row, my values are 0, 0, and 0. Okay. So what I did is I actually plugged 0, 0, 0 at my left side, and I'll be checking every single point. So when I plugged 0, 0, 0, I know this. My pin number 1 of 7400 should be 0, right? Just from here. So what I'm going to do is I'll use my logic probe to touch the pin number 1 to see whether my logic is 0. Okay? Because I have to check pretty much like every single point just to make sure it is working correctly. Okay? Now that means if pin number 1 is 0, then pin number 2 should be high, right? So check both pins. Check the pins because you are using those pins, right? So it's possible that the IC is not working, IC is bad, you might not be getting the same thing that you are expecting, right? Remember, in your circuit, if at any point any pin is not working that belongs to your circuit, your outcome will not be correct, no matter how hard you try, okay? So you should be checking those 2 pins. Now, let's say this pin 2 here, this pin 2 also, you are running a wire between pin 2 and the pin 1 of another IC, right? 7400. Do you see this wire you running? Okay. Now, since you got a high here, you also should be expecting a high in this pin, right? So touch this pin. You already have the logic probe with all the power supply. Touch that pin to see whether you are getting the high. Because you should be actually checking all those pins based on the logic. Because you already have the diagram, meaning the schematic. You already have all the expected outcome. You already know that. So you touch it. Okay. Now for an example, I'm checking some more points. For an example, this point also should be 0, right? Because you see the pin number 10 here is connected to the input A, right? This is my input A. So that means if the input A, remember input A, B, and C, those will be coming from where? From switches, right? From your switches. So this switch here is connected directly to my pin number 10. So I can touch pin number 10 to see whether I'm getting 0 here. That's what I'm saying. So similarly, I also know that my pin number 4 should be 0 because that is connected to the B, right? Do you see the pin number 4 is connected to the switch B? Do you see it here? It's actually connected to the switch B, right? Since the switch B is 0, this also should be 0. Okay? So everything I'm just putting from my outcome. So now I know that switch C is connected to the pin number 3 of my 7404. So this should also be 0. And since this is 0, this should be high, right? The pin number 4 should be high because this is an inverter, right? So I check pin number 4, and I know that pin number 4, we are running a wire from pin number 4 to pin number 9. So let's check pin number 9. So we can check pin number 9 to make sure this is 1. And then this switch, this pin 5 of this IC is also connected to the switch C, right? Do you see the switch C is connected here? So since the switch C is 0, we know for sure that the pin number 5 should be 0. So you can check it using the logic probe. And the pin number 2 here is also connected to the switch C, if you look at carefully, right? So that should also be 0. Now, you have all the inputs for all the NAND gates that we have in the circuit. Now, for the first NAND gate, since this is 1, this is 0, from the truth table, you can tell what should be the output, right? Remember, NAND gate gives you 0 only when all of the inputs are high. All other time, NAND gate gives you high, right? You have the truth table, so you can check it from there, of course. So you can touch the pin number 3 to see whether this is high. Similarly, you can touch the pin number 6 to see this is high, because how do I know this should be 1? I know it from the truth table, right? Truth table of the gates, because I have the truth table of all these gates, right? Now from the last NAND gate here, I know that the output should be high. So I can also touch the pin number 8 to see whether the output is high. Now all these pins like pin 3, pin 6 and pin 8 are also connected to the pin 3, pin 4 and pin 5 here, right? This is a different IC 7410. So now I have my logic probe and I can check pin 3, pin 4 and pin 5 to see whether all of these pins are 1, because this should be 1, right? Now again, this is 7410 is a 3-input NAND gate. Do you see this is a NAND gate? But the only difference is the inputs are 3. So I also have the truth table for the 3 input gates, right, in pause. So from there I know that the output, the final output should be 0, which is the pin number 6. How do I know this is pin number 6? Because I can find it from the data sheet, right, at the back of the lab manual. So I can tell the pin number 0. Now remember, if you are not getting the 0 at the very last step, at the pin number 6 of 7410, that means something somewhere is not working correctly. It might be one of the IC, might be one pin of the IC, it might be some wire somewhere, it might be any register, it can be anything. It can be your switch, it can be anything that you are using in your circuit. So that's why a lot of times just by looking at the circuit, we actually cannot tell why the circuit is not working, because you already built the circuit, you were following all the schematics, and even I can check and it's like everything should be working, but it's not. And remember, starting from the left 4, if your circuit is not working, assume that that is normal, because if you build the circuit and if it is working for the very first time, you are actually lucky, okay? So if it is not working, what you need to do is, I'll give you a small a couple of steps of doing the troubleshooting, including this step where we do the troubleshooting using the logic probe. So you actually need to follow those steps. Okay? What I'm going to do is, when the circuit is not working, I'll let you actually follow those steps. You will actually go over those steps and make a check, that's like a following the steps and put a check mark, okay, on all the steps. You should be able to find the problem, okay? Because this is actually the very rigorous and the last step where you actually use the logic probe. Before that, you probably know it. Because a lot of times what you do is we probably do not have all the connections correct. We may not have we might have some of the VCCs, or some of the grounds might be missing from the ICs. So we actually do all those checking first before we go to this step. In the very last step, we use the logic probe to check the circuit to see all the steps and everything is correct. Okay, because we have also points for troubleshooting in every lab. So if it is not working, you have to fix it. So that's actually part of the troubleshooting. Now, any question here? So when you do the troubleshooting, again, before you start the troubleshooting, you need the schematic. We already have the schematic in POS. We also have the schematic in the manual. In case you don't see the pin numbers in the schematic, because in some cases we don't provide the pin numbers, and that is intentional, because just to make sure you can find the pin number. So because that also needs a little bit of practice. So what you do is, once you have the schematic, if you don't see the pin number, you can always go to the back of the lab manual, right, where you have all the data sheets for all of the ICs. Get the pin number from there, write it down. Once you have this page ready, you can take a printout, right, from any printer. Take a printout, and then you are actually ready for the troubleshooting. So start the troubleshooting using the logic probe. So before you start, make sure you know the pin number, and make sure you also write all the inputs and outputs. So for an example, I know that this input should be 0, right? And then I can use my logic probe to check the same pin to see whether this is 0 or 1 in the real circuit. So I know that this should be 0, but in my circuit, if it is not 0, then something is not correct, right? It might be the IC, it might be the wire. So what I can do is, if it is not matching, I can check and I can replace those. If your IC is bad, nobody can fix it. You have to replace it, okay? But at least you know what is not working, right? So if your wire is bad, you can replace it. So just replace it once you see it is not working, right? So you can actually go from there. So any question? I think once you go to the lab and then once you start the lab 4, and then if you run into any trouble, and if you do a step like this, then probably you'll understand much better than now. So you can always check your result and see why circuit is not working. Let me stop here. Um, this PowerPoint is available under the troubleshooting section in pause. So in case you want to check and go back to this lecture.